You know, when I was thinking about how to present on the argument from so many arguments, I was thinking it'd be a good thing to be sort of like a tour guide, to sit back and look at the landscape and say, hey, isn't this a good argument? And isn't this a good argument? Isn't this a good argument? And then step back and say, hey, isn't this a wonderful landscape? And I think that would be a good approach, right? But I'm sorry to tell you that your tour guide's a little unusual because you've fallen in with a Bayesian tour guide. So what I'm going to do is I'm going to try to help us to think about the cumulative force of the argument by using some Bayesian confirmation theory. So let's see if we can advance these slides. Ta-da! Okay, so the way it's going to work is I'm going to start off with a kind of lengthy section on measuring confirmation. And I want to look at just a really simple case that a statistician, Richard Royale at Johns Hopkins, provides. And the neat thing about Royale's case is that he is not a philosopher, he's a statistician, and he's interested in having a measure of strong evidence. Now, I kind of independently hit on this in a previous version of this paper, and I was talking to Brandon Feidelson, and Brandon said, hey, you really need to go read Royale's book, because he's doing something very similar, and just go and see, because, you know, it seems like you guys are doing the same thing. So what I'm going to do is just look at his case, and it's going to be really fruitful. At least I think so. And then what I'm going to do in the second stage is we're going to look at the cumulative effect of the argument on different sort of assumptions about whether you have strong or weak evidence. And then we'll talk a little bit about independence. Now, sort of the big picture here is I just intend this to be a fruitful way of thinking about the arguments.
I have to disable something on that.
Okay. Okay. So I think it raises a whole bunch of really interesting questions. And these are questions that I don't take myself particularly in my expertise to answer. So I'm looking for sort of you guys to think about how you could develop some of these questions. So the first thing, once we get back to the next slide, is going to just lay out the basic framework. Okay, so I'm going to be talking about probabilities. Right? And usually when people introduce probabilities, right, they talk about probability as a number inclusively between 0 and 1. And you can associate probability with, you know, various propositions. And these propositions have to have various axioms, and so on and so forth. And then people begin to raise objections like, well, you know, does this hypothesis have a probability? Does this proposition have a probability? Maybe it's a range. And I just want to, you know, work with a really weak notion of how we're assigning values to various things. So what we'll see is what we're going to do is we're just going to look at various items of evidence, and we're going to compare the probability of these items of evidence on theism over naturalism, right? So we don't have to assign particular numbers. All we can say is this ratio favorable to theism? Is it unfavorable? Is it an order of magnitude more likely? And so on and so forth, right? So there's some questions here that we can just sort of sidestep. And just as a historical note, I mean, Keynes, who really has one of the first serious books on probability, takes this kind of approach to probability, where it's much more comparative approach to probability, not so much numerical based. Okay, so the next thing is just, if you're interested, you'll sort of know, the notion of probability that I'm going to be talking about is inductive probability. So I don't have in mind a physical notion of probability. Physical probability isn't sensitive to a subject's evidence, so that's not the kind of probability we want. And it doesn't have to do with the subject's degree of belief, because we want something that's normative in a way. At least when we go to have Bayesian confirmation theory and Bayesian decision theory, right, we can say this is the right decision for you to make, the wrong decision for you to make, where that's independent of a subject's particular degrees of belief. And there are two really good papers here, recent papers by Patrick Maher, that develop this sort of Carnapian idea of probability. So I'd encourage you to go read those. They're excellent. Okay, so the next thing that we're going to do when we actually look at the evidence is we're just going to consider two hypotheses. The hypothesis of theism, T, and then I'm going to take naturalism to be not T. Now, definitely false, right? there are lots of non-naturalistic views that are compatible with the negation of theism, but it just makes things a lot easier. So it can be done in a more formal way, right, if you don't like that, but I'm not going to do that. Okay, and then the next thing, hey, Trent, is there a way to get the slides to move up a little bit? Okay, so the next thing is we're going to look at primarily one factor, and so you see there the odds form of Bayes' theorem, and you have let's see, you have over here the ratio of the posterior probabilities. So this is as you take in evidence, suppose you learn a bit of evidence, and then you want to know how does that evidence bear on your evaluation of theism compared to naturalism. And that ratio, right, is going to sort of indicate how the evidence bears on that. And the cool thing about the odds form of Bayes' theorem is that that ratio is equal to the product of the likelihoods and the ratio of the priors. And what we're interested, I don't know what you're interested in, but what I'm interested in is I'm interested in measuring the strength of evidence, right? So I'm going to ignore the ratio of the priors. And that, there are a lot of reasons for that I could talk about, but it just makes it a lot simpler to think about the strength of the evidence when you're looking at that likelihood ratio right there. So that's really what we're going to be concerned about. And now what we're going to do is we're going to look at Richard Royale's case, right, to try to figure out what does it mean when we have various values to that likelihood ratio. Okay, so here it comes. All right, so we have a earn case. Right, this is almost like a professional obligation of your Bayesian. You have to talk about earns. So we've fulfilled this. So earn 1 has all white balls. Earn 2 has an equal proportion of white and black balls. We're going to select an earn on a flip of a coin. Then we're going to select a ball, look at its color, place it back in the urn, and then mix its contents thoroughly. Okay, so now what we want to do is just describe some probabilistic features of Royale's case. So, I mean, this is all really easy. So if you are, a little bit of math phobic, hopefully you had your shot of Benadryl, but it's just not very difficult. So the probability of white on earn 1 is 1, since earn 1 contains all white balls, and the probability of drawing white on earn 2 is 1/2, right? Since there's an equal proportion, and then the probability of selecting either one, earn 1, right, or earn 2 is 1/2 because it's going to be on the flip of a fair coin. All right. Now the probability of selecting white is going to be 3/4. Now, sort of the way to think about this is you have an equal chance of getting either earn 1 or earn 2. If you get earn 1, right, then you're guaranteed to get white. And if you get earn 2, then you got a 50-50 shot of getting a white ball, right? So then you say, well, either 0.5 I'm going to get a white, or 0.25 I'm going to get a white from earn 2. So you add them together, it's going to be 3/4. Now, then we could ask, what's the probability of getting earn 1 given that you selected a white ball? Now, here we use Bayes' theorem, which is that, and not going to talk about that. And you do the calculation, and the probability of having that you're selecting from earn 1, given that you've got a white ball, is 2/3, right? So what you can see is that the selection of a white ball, right, in this case, is evidence that you're selecting from earn 1. So, and then you can see similarly the selection of white ball disconfirms, right, that you're selecting from earn 2. All right. So we have this judgment, right, that white confirms earn 1. Okay. Now, suppose all you learn is that you have 2 draws have taken place and they're both white. Right? Now think about that intuitively. Is that better evidence that you're selecting from earn 1? And you think, yeah, right? If the 1's good evidence, then 2's better, right? And it turns out it's like they offer the same amount of evidence to the Earn hypothesis. And one way we can see this is that when you look at the relevant likelihood ratio, right, the likelihood ratio is going to be the probability of drawing white given Earn 1 over the probability of white given that you're selecting from Earn 2, which is 1 over 1/2, or 2. And that's going to be the same, right, for any white draw. Okay, so when you're going to assess the sort of the cumulative weight of the white draws, right, you're always going to be, in one way or another, adding, right, the same factor because you're going to be tracking that likelihood, which is always going to be 2 in this case. All right, so we have this judgment that multiple selections of white from these Earn independently confirm that Earn 1 was selected, right? That they offer the same amount of confirmation. And what that's tracking is it's tracking the likelihood ratio. Now, in general, if you wanted to know, like, given that we have a whole bunch of white balls that were selected, what does that likelihood ratio look like? It's going to be 1 over 2 to the 0.5, right, to the nth power, which is going to be 2 to the n. Now, the cool thing about this is that now we have a grasp on the relevant likelihood ratio. So we can consider any evidence, right, and a hypothesis and its negation, and we're going to get a likelihood ratio there. So then we can say, well, suppose that likelihood ratio is 10. And you think, well, you get a likelihood ratio of 10. You're like, well, okay, what the heck do I do with that? What's that mean, right? Well, its evidential strength is like the selection of 3.3 white balls in sequence, right? So, and then as your likelihood ratio grows, right, you're going to get, of course, more and more evidence, right, that bears for that hypothesis, right? And then you can take that number and translate it back into the number of balls that would be selected, number of white balls. So, for example, just look. So if your likelihood ratio is 20, that's like the selection of 4.3 white balls. If your likelihood ratio is 1,000, then that's like the selection of 10 white balls. Right? Now, Richard Royal, the statistician at Johns Hopkins, says that a likelihood ratio of 8 is pretty strong evidence. So a likelihood ratio of 8 is going to be like the selection of 3 white balls in sequence. Okay? So, okay. So then there's this other feature of Royal's case that is kind of interesting. Each draw of white is conformationally independent regarding an Earn hypothesis, but the draws themselves are not unconditionally independent. And this is really important for when you're trying to assess the value of diverse evidence. Colin Howson and Urbach have this book on scientific reasoning or something where they're presenting a Bayesian approach, and they're trying to sort of give a Bayesian explication of the value of diverse evidence. And so, like, what is it that makes diverse evidence powerful? And they say that the evidence has to be unconditionally independent. And for reasons I'm going to talk about in a little bit, that's not true. It doesn't have to be unconditionally independent. It just has to be conformationally independent. And what we're going to see is it has to meet a certain kind of screening off condition. This will be relevant to when we go to assess the 24 arguments. Okay, so the draws are not unconditionally independent because, sort of think about this intuitively. What's the chance that you get a white ball on the second draw, right? Well, that's going to be 3/4. But suppose you got a white on the first draw. Well, then that's evidence, right, that you're selecting from Earn 1. So it's going to make it more likely, right, that you're selecting that you're going to select a white ball, right? So the draws here aren't unconditionally independent, but we still have this judgment that they're conformationally independent. And we know, well, what probabilistic feature of Royal's case explains, right, our judgment that the draws of the white offer the same sort of evidential quantity each time you learn of a draw, and it's that they meet a screening off condition, right? The basic idea is that once you select an urn, it doesn't matter what happened before, right? The probability of white on the next draw is going to be whatever, right, it is independently on the urn, okay? So this is gonna matter when it comes to evaluating the cumulative effect of the evidence. If we think of the evidence as conformationally independent, we don't have to argue that it's unconditionally independent. We just have to argue that it's conditionally independent once you fix the hypothesis. So conditionally independent on H and not H. Okay. So let's see. Okay, so here are the key features. So given a likelihood ratio, we can find a corresponding number of white balls. It's a really nice feature. The individual selections aren't unconditionally independent, but they are probabilistically independent regarding H and not H, and then this provides a really clear case of the evidential value of evidential diversity. Okay, now for reasons I'm not going to really go into, when you have these kind of probabilistic features, it uniquely picks out one particular Bayesian relevance measure of confirmation, and that's the log likelihood measure, or a measure that's ordinarily equivalent to that. So the log likelihood measure is right over here. And the way to read this is C, the first part, C in parentheses H to E, is the confirmation, right, that E offers to H. And that's going to be the log of the likelihood. Okay? So remember, like back in a few slides ago, we had a likelihood of 10, the likelihood ratio of 10. And that was like the selection of 3.3 white balls. Well, then the log of that's just going to be 1. Okay, so we'll sort of see how this works in a bit. Now, this is other really nice feature of logarithms is it turns multiplication into addition. Okay, so where we're going with this is we're going to just bring it back to kindergarten arithmetic. We're going to really be adding and subtracting by 1, you know. So just sort of want to lay this out. But so C.S. Peirce had this really cool idea that when you had two arguments which were entirely independent, neither weakening nor strengthening the other, when they occur, they ought to produce an intensity of belief equal to the sum of the intensities of belief which either would produce separately. Now, the log likelihood ratio does this in a way. When you have independent arguments, you can literally just add, right, the strength of evidential confirmation. Okay. So, all right. So here's a table that basically looks at a comparison between the likelihood ratio and the log likelihood ratios. So we have Royale's case, right, where if you get one white ball in succession, right, that's going to have a likelihood ratio of 2. 2 is going to have a likelihood ratio of 4, and so on and so forth, right? So then you look over there, and they're the log likelihood ratios. So just for example, if you're evaluating the strength of evidence, right, and it has a log likelihood ratio or LR of 3, you think, well, what does that mean? Well, that's like the selection of 10 successive white balls in a row. Okay? So, okay. So now we're going to turn to think about the cumulative effect of the evidence. So what we want to do is we want to figure out for each item of evidence or for each argument, what's the relevant ratio? Okay? And we can, since we have this general approach, we can just sort of, you know, fiddle around and see what we get. So what I did is just start off with the idea that the positive evidence for theism is an order of magnitude greater on theism than naturalism, right? So your likelihood ratio there would be 10, the log of that would be 1, all right? Now you might think, is the individual evidence for theism this strong, right? Well, an LR of 1's like the selection of 3.3 white balls, right? So I don't know how you feel about that, but Royale thinks that's pretty strong evidence, not like conclusive evidence. And then it's not unreasonable to think that for some items of evidence, right, fine-tuning the existence of rational creatures, moral obligations, that your log likelihood ratio is going to be 1 or even greater. Okay, so I'm really not committed to what the value is. I just want to put the framework up there for people to think about. The cool thing about this is that, okay, now we're back to kindergarten arithmetic, right? So it's like, if you get an LR of 1, then it's really easy to add together the evidence, okay? So this is really surprising, right? So I don't know which direction you want to do this, but so suppose Plantinga is right, that there are 24 or so arguments for theism, and they're independent in the way it is, probabilistically independent regarding age, not age. Well, that's pretty good, right? How good is that? That's like the selection of 80 white balls in sequence, okay? And you think, wow, that's really powerful, okay? Now, suppose we overestimated, right? And really, there are only 12, right, that are independent. Okay, so you're like, man, that's like half gone, right? Well, yeah, it's like half gone, but it's like 40 white balls being drawn, right, in sequence. So that's extremely powerful evidence. And so on and so forth. So suppose you're like, well, look, there's some basic moves that the theist can make, right? And they're really just 3 independent lines of evidence, right, each with an LR of 1. Well, then your log likelihood ratio would be 3, and that'd be like the selection of 10 white balls in sequence, right? So that'd be pretty powerful still, right? Okay, so then here's just another way to do it, so I just changed it a little bit. But if there are 5 independent arguments for theism, then that's like this selection of 6.6 white balls. If there are 10, 33, and so forth. So the way when I saw this and I was thinking about it, I was like, this is sort of like a Abrahamic confirmation, right? So Abraham's reasoning about with God whether or not he should destroy Sodom, right? And he's like, well, what if there are 50 righteous people? Are you going to destroy it then? No. And Abraham realizes, God can't even resist a Sorites argument. So in a way, it's sort of like this. Like if there are 25 independent arguments for theism, if we got 26, we have pretty powerful evidence. Well, what if we just have 20? You still have pretty powerful evidence. Okay. So you can kind of see why I like this framework. It just makes it really easy, and you can ground these intuitions about strength of evidence. Okay, so another thing that's really nice is that we've just been talking about the positive evidence for theism, right? So now you can bring in the negative evidence for theism, right? And you can just subtract, right? As long as they're independent. And so you can just think about it in terms of like how many white balls does it take away? Really simple. We haven't talked about like what a person should believe because we're ignoring the priors, right? So you can bring in the priors, right? So if you have a really powerful likelihood ratio or log likelihood ratio, and then you think, well, you're not persuaded. So that must mean, right, that your priors are so low that the positive evidence doesn't make a difference at all. And do I have this up here? No, I don't. Okay, so we could, so suppose there are 24, right, independent arguments, each with LR 1, right, and a person's unmoved, right, by the evidence, then their prior on theism has to be 1 over 10 to the 24, right, and that's pretty low. But, the framework just, makes it really simple to think about this stuff. Okay, so what we can say is that if, right, for the individual items of evidence, it has LR 1, there are multiple arguments for theism, then the evidential case for theism is strong. Another really sort of side thing about this way of using measures of confirmation is that there's just no argument about whether or not there's evidence for theism, right? It's just given the formal framework and just given the relevant likelihood ratios, there's definitely evidence. You maybe have to bring in the priors to figure out whether it's believable or not, but in any case. Okay, so suppose the evidence for theism isn't that strong. All right, suppose we have weak evidence. Now, the way I thought about weak evidence is that it was just like a 10th grader, right? So suppose your likelihood ratio is 10 over 9, right? So the theist has a story, and then the atheist or the naturalist has a slightly less plausible story. So your likelihood ratio would look like that. Okay, so how are we going to make sense of this? All right, well, it turns out to be really weak evidence. So in this case, your log likelihood ratio would be 0.04, which is really small. And it would take approximately 22 items of independent evidence to equal the same amount of evidence that you get with one white ball, right? So if you wanted to get back up to strong, well, hold on. If you wanted to get back up to strong evidence, like in Royale's case, you'd have to have 66 lines of independent evidence. So the values to these log likelihood ratios really do matter, and they need to be defended. And Richard has done some really good work in his book. I mean, he wouldn't really put it in defending values to the LR, but that's exactly what it is, right? It's defending substantive values for the likelihood ratios. Okay, so then now what do we have? Okay, so other models. So this approach makes it really easy to sum the cumulative strength of evidence. So you can just think about the evidence, and you can sort of, maybe you don't feel confident saying it's an order of magnitude, 2 orders of magnitude, or whatever, but you can just think in terms of sequences of white balls, right? How correlate that to find a corresponding LR, and then just add to get the cumulative effect. If the items of evidence are such that they have different values, that's not a problem. We're still adding. And then you can just take in the evidence against theism and then just add together to get a final judgment of how you're going to measure evidential strength. Okay, so what's next? Okay, so one of the key questions here is whether the arguments are conditionally independent regarding theism. All right, so we have here the definition of conformational independence from Brandon Feidelson, which I'll put up there. I won't read through it. And hopefully I have the screening off condition. Yeah, I do. Okay, so what crucially has to hold, right, in order to add in the ways we've been adding is that for each item of evidence, the ratio is unchanged once you add in the other items of evidence. Okay? So that has to hold. So let's see. So then the question is, how many items of evidence or arguments are such that this screening off condition holds? Now, I don't know. I mean, that's a question, right, for people to figure out. So on the plane ride over here, for what it's worth, like back of the envelope, sort of, calculation or whatever. It just seems like, okay, well, at least the ontological argument, cosmological argument, teleological argument, moral arguments plausibly meet condition S. You got to sort of reformulate them a little bit, but they seem like maybe they plausibly meet condition S. It seems like multiple design arguments don't meet condition S. And what was kind of cool is that, so Trent and I wrote this paper in grad school where we were worried about like how multiple design arguments are formulated in a cumulative case. And it just realized by thinking about this framework that really what we were worried about is a screening off condition with multiple design arguments. And then several of the 24 or so arguments presuppose intentionality. So they're not going to meet condition S. And so the question is, the question is just how many are there? And I throw that question back to you guys. Okay, so then there was a section in between here on more generally the explanatory virtues, because in argument Z, Plantinga says things like, the theist arguments import a great deal of unity into the philosophical endeavor. And I think that's a really interesting idea to think about how theism could have the virtue of unification in a way that's similar to other scientific hypotheses. And another idea that's sort of suggested by his remarks is that theism is fruitful in various ways. And it would be a fun project, I think, to try to figure out, like, to what does theism make predictions, right, about ways we should, things we should find in the world in a way that's similar to, Darwinian hypothesis being fruitful, right? So it's fruitful. Darwinian hypothesis is fruitful in a way that you should try to find some mechanism for genetic change, which led to the development of molecular genetics, right? Eleanor Stump has been recently doing some work suggesting that theism fits really well with the development of neo-Aristotelianism in biology, because theism postulates things like persons, right, which have non-reducible causal powers. So this is something that I'm interested in. I kind of wanted to put the slides up there, but I didn't think I was going to have enough time. So this is another thing that I sort of throw back to you guys, to think about. Okay, so conclusions. All right, on relatively weak assumptions, theism has an evidential case as strong as the selection of 16 white balls in a row. So I think you can at least get back to an LLR of 5. All right, pretty cool. If the 24 or so arguments are probabilistically independent regarding theism, then the evidential case for theism is like the selection of over 80 white balls in a row. And then we can just take into account the entire case, right, using the method that I've provided. So is that it? Yeah, that's it.
Now, Ted started talking before I had a chance to finish my introduction of him. And Ted and I, as he mentioned, were in grad school together. And Ted was absolutely my best friend in grad school, hands down. Somebody that I love, who is a good husband and father, a great philosopher, a humble man. And it's really great to see you here.
Thank you.
And when we presented this paper at a Society of Christian Philosophers conference, where Al Plantinga and Robin Collins were in the audience,
Yeah.
and we were just like really kind of freaking out when we saw them there. And they both made good comments, and they both came up afterwards and were very gracious and thought it was a neat paper, and we're still working on the stuff related to this. Okay, so now we'll take questions. Robin, you'll get the first one.
I guess my immediate problem is in the last slide, and maybe I just missed something because I'm a little sleepy right now. I don't see how, the ontological argument, let's say you have that, that's one of the E's, right?
Yeah.
I don't see how you actually have any expectation of that on theism. Mm-hmm. Or the cosmological argument, okay, given theism, how much would I expect there to be a contingent world? It doesn't seem those arguments work that way.
Yeah, so this is a question about the model. It's like, how do you translate some of these traditional arguments back into this model? So Alex and I were talking over email about this. Like, just take the ontological argument. Like, Plantinga's version of the modal ontological argument. You think, well, how does this fit into this Bayesian framework? So, like, you just put the entire argument into E? That just doesn't make much sense, right? So you have to do some reformulation. And the thought that Alex had was, well, what if the datum is that it initially seems possible that there's a maximal being, right? And so you would have the probability of that given theism over the probability of that given naturalism. And, that would seem to be favorable, right, for theism. That given that there's a God, we should expect that, just the ratio, right, would be favorable to theism.
You wouldn't have a modal intuition you wouldn't have otherwise.
Yeah.
Yeah, it would have less likely.
Okay, next question, Richard Swinburne.
Really a follow-up to this. As you know, the probability of any necessary truth on any theory at all is 1.
Yeah.
And that means that no necessary truth can be evidence for theism. Mm-hmm. And half the arguments given in this conference seem to me to, without the reformulation suggested, to be starting from necessary truths.
Yeah.
I mean, one way of phrasing the ontological arguments, necessary truth, in a simple version of it, is things that things which are more perfect are more likely to exist than things which aren't perfect, or something like that. And then but then either this is a necessary truth, in which case it can't confirm, or you have to rephrase it in terms of it seems to me that. So there is and the question then is, what about the me's? Who is me? And you could rephrase it in. It seems to a majority of people in a random sample or something like that. But it really does seem to, a more plausible way of setting about would be surely to say that the traditional axioms of the probability calculus won't do for this kind of case.
Yeah, that's it. That's exactly right. I've been wondering about this myself, and I don't have any answers. So one thing you could do is you could just restrict to contingent facts, right, and see how this go. But with these other arguments, I mean, you have the strategy you said, reduced to it seeming this way to a person. I wonder if you can't, like people have been working on counterpossibles. I don't know if that's one way to develop it, where you can have probability measure over everything that could be and everything that couldn't be. Then it seems like you're going to face certain kind of normalizability problems. But this is one of those questions that I think I wanted to just put out there, is we have this really neat model where we can measure confirmation in this way. There's some questions about how does it work with metaphysical arguments for things that are either necessarily true, if they're true at all. So I'm not exactly sure, but there's some ways you can go to accommodate those.
And there's already independent reasons for thinking that the standard Kolmogorov axioms aren't going to be right for epistemic probability. Oh, Dan, sorry. I get you too confused all the time. We're the same guy.
There are two things that worry me here, and one is something brought out by the model, and one is about the adequacy of the model. Okay. So first of all, if somebody pulls out a black ball, it absolutely determines that we're in the other urn, right? Yeah. And so you might think, look, what if we've got 24 or 26 arguments on this side? It's equivalent to pulling out all of these white balls, but then there's one black ball on the other side. That totally destroys it. And you might think there could be an argument on the other side, like the problem of evil, or something about the incoherence of omnipotence or something that would actually have that force. So that's the first worry. And the second worry is about the adequacy. It's as if a paper on arguments for God's existence is actually saying, well, I'm now giving you glimpses of the white balls I pulled out of the urns. I'm not going to tell you about the ones on the other side. Wouldn't we need to know, even if it wasn't the case that one of them had no black balls, so that it was a fairer modeling, wouldn't we need to know about the arguments on both sides, as it were? Which white balls and which black balls did you pull out of the urns before we can reach any conclusions?
Okay, good questions. So the first thing is just the point of the Royale's model. So the point of Royale's model is to associate values with the likelihood ratio with something that we can make sense of, like how strong the evidence is. So all that matters for his model is that the selections of the white balls are probabilistically independent regarding the urn hypothesis, and then given multiple selections of white balls, that's going to give us a specific likelihood ratio. So the presence of the black balls, and if you draw a black ball, then you're selecting out urn one. Just doesn't urn two just isn't relevant for the overall purposes of associating something that we have more of a cognitive contact with than just bare numbers for the likelihood ratio. All right, and then the second point is one that I think is so then given that we have a model for associating something like a natural case with values to the likelihood ratio, we can then use that sort of in reverse, right? So when you're looking at the evidence against theism, right, if you have something like logically conclusive, right, reasons to think that theism is false, then it takes away, all the white balls, and that. But if it's just really strong evidence, then you can just associate it with the number of white balls it would take away, right? So one really nice way of thinking, one really nice feature of this model is thinking how powerful is the evidential case from evil, right? So suppose you have a string of, so you can kind of think about it like this, like given the facts about evil, right? How surprising would you think it to be that you're in a world in which there is a metaphysically perfect being? And you think, oh wow, that would be like the selection of 80 white balls, right? In which case the negative string, I don't know quite how to say this, but your LLR would be negative 24 when you add in that. So it would be powerful evidence indeed. So this is one of the things that I think this is one of the reasons the statistician Royale really likes this kind of approach, because it makes tractable, right, these kinds of questions.
Tim McGrew?
Thanks, Ted. I think one of the things that makes this so difficult is that many of the arguments, at least the way that Plantinga originally sketched them, are given as deductively valid arguments. And those pose special problems when we try to incorporate them into a probabilistic framework for evaluation. There's a paper by Augustus de Morgan in the Transactions of the Cambridge Philosophical Society from 1849 that's worth reading, even though I think in the end it's kind of a magnificent train wreck. But he's trying to do just this. He's trying to take multiple deductively valid arguments with premises that are maybe independent in some sense. Part of the trouble is he's not quite clear on that. And try to see, some of them maybe for a conclusion, some against, and he tries to combine them. And it's really hard. And I'm not sure there is a general framework. If there is, I'm pretty sure we haven't found a general framework yet for giving a decisive answer on that. Here's a different line of approach that might prove fruitful. If you let's take a very simple example like the version of the Kalam argument that Bill Craig was giving to us. Two premises, deductively valid. And let's just waive for the moment questions about the fact that not all of the arguments have exactly the same conclusion. That's another complication. But set that aside. If each of the premises of that deductively valid argument has a probability of 0.6, then by the theorem on the accumulation of uncertainty, we can say that the conclusion must have a probability of at least 0.2, possibly more all the way up to 1. That provides us a different point of entry. We can say, hey, if an argument like that can get a conclusion on the table for discussion, that is a motivation for looking into other arguments, and perhaps in particular looking into evidential arguments that have a formulation more amenable to the kind of Bayesian calculation that you're giving here, and we can take the lower range of that interval as a sort of worst-case scenario for a prior probability.
So I have some questions about that, which we might be more productive to talk about afterwards. But in that case, if you have a lower range, can you still add to raise the lower range up when you have multiple? Okay.
Yeah, but not necessarily as conveniently
in this way.
The system you've been outlining here.
So the other thing I was thinking is maybe a different way to apply this approach is to. So it's often the case, it's often, nearly always the case, that deductive arguments rely in some way on further inductive arguments, right? Where you get to the point is like, well, really what there is this disagreement about this premise way down here, right? And we don't know that, but you could make a judgment to the effect that, well, how likely is that given theism, and how likely is that given naturalism? And in that way, what you could do is sort of have a more general sort of family approach to the argument. So there are a number of various basic moves that one could make, and would get independent support in that way.
Yeah, actually, I wanted to point out something Tim mentioned briefly that kind of went in a different direction. So the arguments actually don't seem to have the same conclusion as a target at all. I mean, a prime mover is not the same as an ultimate brain or thinker or source of propositions. So, I mean, can you really add them together if they're not? I mean, those are all definitions we may hold synonymous with God, but they don't actually. Don't all actually have the same target. They're not, maximally good being, for example.
Yeah, that's a really good question. So the way I was thinking about it is that one of the nice features of this approach is that you get to specify what your hypothesis is, right? So the hypothesis is that there is a being of pure, limitless, intentional power, right? That there's this O3 being. So I forgot who it was that mentioned earlier in the conference that one of the problems with these multiple arguments is they have different conclusions. And how do you get, right, to an O3 being from these arguments? Well, this approach it doesn't have that problem, right? You specify what your hypothesis is, and then you figure out what the likelihood ratios are. Now, as Swinburne has stressed, it's really important that you pick a good hypothesis, right, that's simple. This is why Swinburne prefers to think about God as a being of pure, limitless, intentional power that has one property with no finite limit, right? So it's to ensure, right, that it's a simple hypothesis, and then from that, right, you get arguments to the effect that your likelihood ratios are going to be thus and so.
You might also do something like Lewis and specify that your hypothesis is something like that naturalism is false. Yeah. And then any of those conclusions to that.
Yeah.
Thanks for a very great educational paper, certainly for me. Here's a constructive suggestion about how one might go about, you might say, arguing from all the arguments without having to sum them or deal with them in the way that you have. Particularly when you have problems, some of them are deductive, some are inductive, and so on. It's, I think, pretty well accepted both by believers in God and unbelievers like Schellenberg that something like this, that if there's a God, it's likely God would want people to know about him. He would make his reality easy to know, widely accessible in my terms. But if the knowledge of God is widely accessible, we would think that there would be lots of reasons to believe in God, whether that reason consists of inductive evidence or other kinds of there could be different kinds of reasons. If we find ourselves in a situation where wherever we turn, whatever we look at, turns out to provide us with a reason to believe in God, that fact itself could be made into a probabilistic argument confirming the hypothesis that God exists, because that's one of the things we would expect to be true.
Yeah, that's right. So one way to take this model, so Brandon Feidelson has been very helpful in thinking about this paper. I've had multiple conversations with him. And one of the things that we've talked about is on this kind of model, if there are all these many independent arguments, and they have log likelihood ratios of 1, then you get really powerful evidence for theism, and then you can sit back and you can think, is the case really that good of an evidential case? Or you could go the other way. You could think, wow, this is really great evidence, and so this is even more right evidence that there's a God, like you were suggesting.
Last question of the whole conference goes to Alex Bruce. No pressure, Alex.
Okay, it's actually, I want to reprise Dan's question and then turn it into a question for Al, actually. So suppose that I pull out balls from an urn and post photographs on my blog, 1 photograph a day for 3 weeks, and I post a picture of a white ball for each day, and you say, that's great. We've got a great hypothesis, a great confirmation for urn 1. And then you learn that what I do is I pull out balls from the urn. If it's a black one, I put it back. If it's a white one, I photograph it. Now you have no confirmation. So the question for Al is, when you work on this stuff, did you find any black balls we don't know about?
Well, I think there is only one sort of black ballish thing in the neighborhood. It's not exactly it's not a black ball at all from my point of view. But I mean, that's of course the problem of evil. That's it's hard to know exactly how to think about that. I mean, one way to think about it is, well, we just don't know why God permits evil. Maybe we wouldn't initially think God would do such a thing. We don't know why he does it. But then the answer comes, well, why would you think you'd know about that? You know, I mean, maybe God's got other considerations that you haven't thought about. You know, his options and so on are beyond your ken and the like. So I don't really know how much stock to put in the problem of evil as objection to theistic belief. And I can't think of any others that are that have any force at all. I mean, some people think the notion of omnipotence is incoherent, but the reasons given are typically pretty foolish, I think. I mean, maybe you know better reasons than I do, but ones like, could God make a stone so heavy he couldn't lift it? You know, well, if he can't do that, he's not omnipotent. But if he could, then if he did it, then he wouldn't be omnipotent. So, you know, that. But I don't know of any serious arguments for there being an incoherence in the notion of omnipotence or omniscience or a combination of these attributes. So as far as I'm concerned, the only black ballish thing in the neighborhood, and I'd say it's at best gray, would be the problem of evil, right? And while I've got this thing, while I've got this thing, I want to say one more thing. I've just been delighted by this conference. I mean, I'm so impressed with all these smart young people that come up with things I never would have thought of, you know, and that are really worthwhile to think about. I'll just say it once more. I'm delighted. I'm genuinely delighted, and I'd like to thank the people who organized it, Trent and whoever else is involved. Thank them once more. So.